Okay, let's do a problem with repeated eigenvalues. So the idea here is we solve a minus lambda I times some vector k equals 0. We do the determinant of a minus lambda I equals 0, and we get our solutions, but we get a repeated eigenvalue. We get the same eigenvalue pop up more than once. Then once we get that, we still need to find k using this, and then we need to add on some extra stuff to find our first solution. So x1 will be that k e to that lambda t. x2 will be that times an extra t. We pick up an extra t just like we did in one dimension. But now we need to add on this extra particular solution, some vector p times e to the lambda t. And that vector p has to satisfy a minus lambda I times the vector p equals this vector k we had, our other eigenvector. So this is the mathematics behind it. Let's do an actual problem. So let's say we have this system here, x prime equals 7, 1, negative 4, 3 times our vector x. We want to find the eigenvalues of this matrix, so we're just going to jump straight into, we want the determinant of a minus lambda I. So that will be 7 minus lambda, 1, that's a 4 there, negative 4, 3 minus lambda, so that's 7 minus lambda times 3 minus lambda, 7 lambdas look a little too much alike, plus 4 equals 0. Okay, that reduces to lambda squared minus 10 lambda plus 25 equals 0, which is lambda minus 5 squared equals 0, so we get lambda equals 5 twice. Write it twice if we want. So we have a repeated eigenvalue. We got the same eigenvalue twice. We need two linearly independent eigenvectors, so we can't just do what we did before. Our first eigenvector so k1, or just call it k, we solve a minus lambda I times k equals the 0 vector. So this matrix now will be 7 minus 5, 1, negative 4, 3 minus 5, times k1, k2 must equal 0, 0. Remember, that's the 0 vector. So that's 2, 1, negative 4, negative 2, k1, k2 equals 0, 0. Remember, this is always going to be the same equation twice. We can use the top or the bottom. It's always the same equation twice. So just multiplying, let's just use the top. We get 2k1 plus k2 equals 0, or 2k1 is negative k2. Now we can pick anything we want for k1 and then solve for k2, except 0. We can't make either of these 0. When we get to p, we can do that. So I like to just swap the coefficients. I'll make this guy 1 and that guy 2. Or negative 1. That one's a negative 1. So k1 is negative 1. K2 is 2. Okay, I could have easily put the negative on the other one. It doesn't matter. I could have called K1 7, and then K2 would have been negative 14. I can make up whatever I want for one and then solve for the other, as long as it's non-zero. All right, now we need to find our P. So we're going to solve A minus lambda I times some vector P is equal to that eigenvector K that we just found. This is the guy we just found. So that will be, same matrix here, 2, 1, negative 4, negative 2, times P1, P2 equals, and what did we have? I think we had negative 1, 2. Again, these are not independent equations. These equations are dependent. We just need to solve one of them. So I'll do the top one. Row times column equals the top element, 2P1 plus P2 equals negative 1. Now here, we're allowed to choose, make this easy. We can choose one of these to be 0 and solve for the other one. So for simplicity, we'll let P1 be 0. We can't do that with K, but we can with the P. Then P2 is negative 1. And we can put this all together now. This is our vector 0, negative 1. Our solution will look like x equals C1 e to the, what was our eigenvalue, 5t, times our eigenvector, negative 1, 2. I need more space here. So our general solution is x equals C1 e to the 5t, negative 1, 2, plus C2 times all of this. We get this extra t, e to the 5t, times that eigenvector, negative 1, 2, plus that p we just had, which was 0, negative 1, 0, 1, e to the 5t. Okay, so if we wanted to write out, remember this is the vector xy. If we wanted to find x, we'd have to go all the way across the top. So x is C1 negative C1 e to the 5t plus C2 t e to the 5t, that also has a negative on it, plus 0 of those, and y would be 2 C1 e to the 5t. I'm just going all along the bottom here, plus 2 C2 t e to the 5t, plus, and then this one here, e to the 5t. So there's the solution to this system of DEs.